All right, so this is the last podcast of Unit 1, and we're talking about density. This is just going to cover the top part of page 18. We'll finish up those last few problems in class as we're working on reviewing as well. So, what is density? We've talked about it a little bit earlier in this unit, but it's a ratio of mass per unit of volume. And really what it comes down to is it measures how tightly packed our matter is. And when we talked about it before, we were focusing on the fact that it's intensive. If we have more or less of a substance, it's going to have more mass and more volume. So that density is actually going to stay the same because that ratio of mass to volume will stay the same. So that's not to say that we can't change an object's density. When we have it melt or boil or freeze, those particles are getting closer together or farther apart. So we can change an object's density with temperature or phase changes, but for a specific substance like water, at a specific temperature, it doesn't matter how much or how little water you have, the density will be the same. So next, what's the formula for density? Well, density D equals m divided by V, and that m stands for mass, and our mass is generally going to be measured in grams. That V that we're dividing by is volume, and we're either going to have our volume have the units of milliliters or centimeters cubed. They are equivalent. 1 milliliter is equal to 1 centimeter cubed, so people kind of use them interchangeably. And then, of course, D is density, and the units for our density are going to depend on kind of the units for our volume, but it kind of just ends up getting the math that we did to our numbers with those units. So it's going to be grams over milliliters, or grams divided by or over centimeters cubed. So those are the units you'll put on your density if you're solving for density, or if you're given some numbers, you can identify the density by looking for those units. Now, if you're asked to solve for density, you just need to do mass divided by volume. But if you're asked to solve for mass and you're given our density and our volume, then this equation is going to need to get rearranged. So if we wanted to get mass by itself, we'd have to get rid of this divided by volume. And hopefully you realize that would mean we'd need to multiply by volume on each side, so it would cancel out. And what we're left with is the fact that mass is equal to density times volume. On the other hand, if we wanted to solve this equation for volume, the first thing we'd have to do is get it out of the denominator into an equation like this. And then if we want to get volume by itself, we'd have to be dividing by density on each side, so it would cancel out and go away, which means that our volume equation is going to be mass over density. So if you're asked for density, you have this equation given to you, you can just plug it in. But you're oftentimes going to be asked to use your density to solve for either volume or mass. So you might have to do a little bit of algebra there, but our density can also be used in dimensional analysis as a conversion to help us. If we do have it given to us and we're asked to solve for mass or volume, we can also use dimensional analysis, and I'll show you an example of that in a moment. The first problem, though, asks us to solve for density, and this is just easiest to plug straight into that density equation. Density equals mass over volume, and we just have to look at these numbers and make sure we can tell the difference, because it didn't tell me which one is which. But remember, mass is measured in grams, volume is measured in milliliters. So we're going to be taking this 3, 6, 8, 2, which is our mass, dividing it by 53.4, which is our volume. And our unrounded answer here is 68.9513, and there's a lot more digits there. But looking at the sig figs in the numbers we were putting together, 3 sig figs is the least number that we started with, so we're going to keep the first 3 sig figs here. That does mean that this is going to round up to 69.0, because that 5 rounds the 9 up, and then the 9 rounds the 8 up. But 69.0 is our 3 sig fig answer, and then we just need to put some units on it. And since we did grams divided by milliliters here, that's what I'm going to do as my units for this density. In the next problem, we are given the density and asked for the volume of our sample. So we're going to go ahead and use that rearranged volume equation. Volume equals mass divided by density. And we can find our mass as this 15.5 grams, and our density is 19.3. And if we do that division, our unrounded answer is 0.80310, and both of these agree. These are 3 sig figs, so we want to keep these 3 sig figs, and our final numerical answer is going to be 0.803. And if we're looking for volume, remember we can use either milliliters or centimeters cubed, and that, since I saw milliliters here, that's what I used. Now, I mentioned we could also use density as a conversion factor. So let me show you that. This is the exact same problem I just worked out before. But now, if we use this density that's 19.3 grams per milliliter, and we kind of break apart the grams and the milliliters. When we say grams per milliliters, that means we have 19.3 grams in 1 milliliter. So this is going to be our unit equation, our conversion factor that we use here, and our mass is going to be our given. So we're going to put 15.5 grams here, and then because I had grams as my given, I'm going to take the grams side of that density equation and put that on bottom, and put the 1 milliliter on top. And notice how I've got 15.5 over 19.3 again. I'm going to be dividing those two numbers just like I did when I rearranged that equation. But here, I didn't have to do the algebra or memorize what that rearranged equation was. I just used dimensional analysis and pulled apart that grams per milliliter into a simple equation. So once again, my answer ends up being 0.803 milliliters. Exactly the same as before. Does not matter to me which way you work these problems, but it's really only when you're given a density that you can use this for dimensional analysis. If you're asked for density, just do mass divided by volume. So here, we're solving for mass, and so here, we're probably going to want to do our mass equals our density times volume. And our volume is 32.5, our density is 1.83. So 1.3 times 32.5 is equal to 59.475. 3 sig figs is what we want to keep, so that's going to round 59.5 grams. Pretty straightforward, I hope. This last question has a little bit of a trick in it, and I'm going to help you deal with that, and then I want you to try and find this final answer. And the little twist is that it's asking me for the density, so I think this is a pretty normal looking problem. I go and I find my mass. It even made sure I knew that that mass was 147. And then I have a whole lot of volume numbers. It was placed in a 50 ml graduated cylinder. The water level rises from 20 to 41. So which of those is my volumes? Well, technically none of them are. When we're reading this, we place that piece of metal into 20 milliliters of water, and that caused it to go up to 41 milliliters. So the volume of our metal is the amount of volume that we added to that graduated cylinders. So in order to get from 20 to 41, we added 21 milliliters. So the volume of our metal, whatever weird shape that metal was 21 milliliters. So you are going to need to divide by 21, but I want you to make sure to round this answer appropriately and put some units on it. And let's see if we can all agree on that answer.